Hi guys, we are continue solving Leetcode. So let's share our screen and check our next task. So our next task is farthest building you can reach. So let's take a look. Okay, so you are given an integer array heights, representing the heights of building, some bricks and some ladders. You start your journey from building 0 and move to the next building by possibly using bricks or ladder. While moving from building I to building I plus 1, if the current building height is greater than or equal to the next building height, you do not need a ladder or brick. Okay. If the current building height is less than the next building, you can either use one ladder or hi plus 1 minus hi bricks and return the farthest building index you can reach if you use the given ladders and bricks optimally. Okay, and here we actually have this situation. So we have some heights, bricks, and ladder. And for example, here we have like 2 ladders and 10 bricks. So if we like use here 8 bricks, then we go here, then we have 2 bricks, so we use like ladder, another ladder, and yeah, we finalize here. So it's like so here we finalize like 1, 2, 3, 4, 5, or like 4, and here we finalize like 0, 1, 2, 3, 4, 5. But if we will use, for example, here ladder, then here we can use bricks, for example, and we will use like 5 bricks here. Then we use another ladder, then 2 bricks, and yeah, and we finalize on 3. So actually, what we can do, we can try different approaches, like to use ladders and to use bricks. Like for example, here, like we should maximize the number of or minimize, like to use minimum bricks. So here we can use ladder, then use brick, and then use another brick. Okay, but here we can use bricks, right? And go to the last element. Okay, let's check. Heights. So if we have like all heights that is greater, and we have, for example, bricks, like 2 bricks, right? So we use 1, 1, then we can use also ladder. And if we will check, like we can have a lot of bricks and also a lot of ladders. So actually we should decide So when we on some position, we can make a recursive call for using in one case bricks and in other case letter, and then go another recursive call, and when we return actually, then we get the result. So in this case we have solutions. So first solution would be to iterate through our heights and check the next brick. And if the next brick is greater, then we have two operations: to use bricks and to use letters, and then to take the maximum index from these two. And we actually start from the first position. So we have recursion call. So in this case, we have all of like for example, for each situation we can have like two options, and then again two options, again two options, and again two options. So the high would be 2 of n, 2 of n. So it would be the high of our recursion call. Recursion call 2 of n, right? It's time space probably n. Here I'm not sure, so I should check after this. So it's actually DP approach, or like not DP, it's backtracking approach. DP approach, it would be if I have memoization, but I think here it's needed actually. So probably I need DP approach here. So let's try. So I have my recursion call, I have my int, and in this recursion call, I should get I, right? So it would be index where I currently in, and also I need to get my array. Also I need to get bricks and ladders. And base of recursion would be the following. So for example, I'm standing on the last position. So in this case, I'm return array length -1. If it's not last position and I have yes, yeah, if it's not last position and I have situation when my next brick I+1 is greater than current brick, and for example letters is equal to 0, and bricks is less than array I+1 minus array I. In this case, I'm returning I. Okay. Otherwise, I'm actually what I should do. Yeah, I should check if array I plus 1 is, yeah, if array I plus 1 so let's say I also have int result, and int result would be I, and here if I r plus 1 is greater than ri, then I do two calls actually, two recursion call, I plus 1 array yeah, I think like if also bricks is yeah. So recursion call I plus 1, then array B. So if let's say bricks, if B minus, yeah, if array I plus 1 minus array I is greater than B, in this case I should return I. Otherwise I should make recursion call I plus 1 array, and here should be B minus this one, or minus array I, and letters here, and also letters. So with letters I actually just make recursion call with I plus 1 array B and L minus 1, and here I can check like if letters is greater than 0, then I do this one, otherwise I do I. And yes, have my result, otherwise yes, so here result equal to mass maximum from bricks and letters. Here result maximum, not maximum but result recursion call, just I plus 1 array B and letters, and then return result. And at the beginning I should return my recursion call. I'm start with 0, I have my heights, bricks, ladders. Let's run it. Mm-hmm. Greater recall can be like this. So index 8 out of bounds of length 7. Mm-hmm. Okay, so how is it possible? How is it possible to get this out of bound? Let's print. So I have 0, 1, 2, 3, 4. Array 7. Okay. 1, 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Yeah, but how can I get 8? I don't understand. Because here, if I is greater or equals than, let's say, not greater, equal to array length minus 1. So if I is equal to 7, then I return my length. So I don't understand why I'm going here. Line 14. Array I plus 1. Return I. Okay, why don't get? like 4, 5 plus 1, like array with 5. It's okay. Yeah, I don't understand. I don't understand why it's index out of bound, because I should return it here. Okay, int array I plus 1. And here it will be a equal to a. A2 2 7 14 okay, so 0 1 2 3 4 5 14. Okay. Um, hmm. Okay, and if I will change this to a, for example, would it change something? Okay. Yeah. Output limit exceeded. It's actually when we have a lot of elements. So for sure we should have some memoization here. So memoization would look like the following. We should get, we are getting result on some I. So let's have kind of map, integer, integer. It will be memo, new hash map, and in result we will just put memo put I with result. And here, if memo get I not equals to null, then return this one. Okay, let's try. Okay, wrong answer. Bricks 4, leather 1, output 3, and expected 5. So for example, we can get on this one, then use letter here. No, we can use letter here, then go here, use one brick here, one brick here, and one brick here. And we will be like on 0, 1, 2, 3, 4, 5. So yeah, expected 5. So let's check why it cannot be work. So at the beginning we go on 0, I is equal to 0, and yeah, array length 7, and I plus 1 is 5. Yeah, that's correct. So what I'm check? I should have also information about ladders. So let's go not array lengths, but I'm interested in bricks and also ladders. And yeah, let's have this test case. 4, 1, 1. So I have 4 bricks and 1 ladder. Then I use 4 bricks here, right? Yeah. So what I check, yeah, if this one is, so I can use, let's call it next, 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 next. Okay. Yeah, so if next is greater than minus this one is greater than breaks. So yeah, 5 minus 0 is not greater than breaks. Yeah, not 5, like 5 minus 1 is greater than b. Then I. But I go to this recursion call with, yeah, this b. So for example, I use here b. Then when I use this one, I should go to this ladders actually. And I should use 1 ladder here. And yeah, let's also print some map results. Okay. Map. Check. Let's check. Okay. 0, 1, 3. Yeah, it's interesting. Like when I done this recursion call, it would be 1 array, then b minus this thing. So bricks 0 and ladder 1. So it's correct. Then 1b, then I check. Okay, next one is yes. So yeah, I don't use So I check that if next one is greater than I. Next one is not greater than I. And here also next one not greater, so I go to this recursion call. Yes. And go here. Yeah. Then I go here. No, I like go here. I call this recursion call. And yeah, when it's 0 and 0. So I check like next, ladder is equal. And next minus is greater than b. So I return I actually here. And yeah, in this case, our bricks and ladder result. Yeah, I don't understand why I'm not going to, like on this first why I don't know, I'm going here. Recursion. Let's let's do the following. So I always call recursion and also I have one additional if, for example, if b is less than 0 or L is less than 0, then I return I. Okay. So I do these two recursion calls and then take maximum. Yes, this one I done it. Three and 5. Yeah, the same. Okay, white is the same. B minus. Next. Let's call it here, for example. So after first recursion, I have BR is equal to BR and LD is equal to LD. Mm-hmm. 3 LD3. Why 3 actually? So for example, I call LD Yeah, for I equal to BR3, for I equal BR, I plus 1, ladder minus 1, ladder minus 1. Okay, now get. I think this one is not needed. Let's try. I don't understand why it's not going. Like I call I equal to I plus B equal to B plus L equal to L. So what calls I have? Calls with 0. Okay. Where my call with another 0? Or not in another, with I. Well, here. Okay. Call with I before L0. Nice. Where my call with I2 before and L0. So let's check. Okay. I'm take my next. Currently is 5. So next would be 1 minus 5 minus 4. Minus 4 is greater than B? No. So I'm not good here. My result, I. Okay. Then I check. Next. Next is greater than I? No. So I just go here. So I don't understand why I'm not going here. Probably because I already maybe put in the map. Okay. We have 0, 1, 2, 3. Then 0, 0, 0. Call 1, 3, 0, 1, 2, 3. Now I use bricks, right? Then I skip this, then I use ladder, and here I return. So it would be my recursion call. Minus one letter, yes. L equal to 1. Okay. Okay. Okay, I think that I cannot solve it, so let's stop it.